Strings and lines, problem 1. So this is the first video of our strings and lines series, which will be working with, strings, lines, and different questions asked about them. For example, folding, intersections, overlapping, that type of thing. But the main solution to all of these problems would be making tables and finding patterns. And we can always, because the numbers are going to get bigger and bigger. And it's not like, say, if it asks us to fold a string 1,000 times, we're not going to actually do that. So the main point here is to start at the beginning. Start from the very, very easy scenarios, for example, 1 fold, 2 folds, 3 folds, 4 folds, all the way up to 1,000 until we find the pattern. So in order to get what I mean, let's take a look at problem 1. Take a string and fold it in half. Fold it in half, so fold it in half, fold it in half again, then cut straight through the middle. How many pieces are cut? That's very hard right now because especially I don't have a string next to me. So if you do, of course, you're welcome to try. But I'm going to be drawing pictures. Alright, so this is stage 1. I haven't folded it yet. So this is what it looks like after I fold it, right? Fold it in half. Now we're going to fold this in half. So how do we do that? Well, just observe closely and it'll kind of look like this. So fold it in half, fold it in half. And this is just asking for 2 folds. Then you want to cut straight through the middle. How many pieces were cut? Well, one way I could find this is just by counting. So I see 1, 2, 3, 4, 5. So 5 pieces are cut. Of course, that's always an option with some of these basic ones, but that's not what we're looking for in this series. We're looking for the ability to make tables. What if I asked you, say, to have 12 folds, and then cut it straight through the middle? How many pieces will be cut then? That is when tables comes in, because tables is a very, very important tool when it comes to helping us find patterns. And patterns are helpful because no matter what value you have, using a special, say maybe equation, expression, you always know what's going to come next. So over here, I'm going to name what's going to be the values of this first row and second row. For the first row, I'm going to have it being the number of folds. Okay, because that's something that changes. And as the number of folds change, the number of pieces change, right? The number of pieces after you cut it with a scissor. So, what if there was only 1 fold and I cut it in half just like that? Well, there would be 1, 2, 3 pieces. 2 folds, we just tested that out. That would be 5 pieces. What about 3 folds? 3 folds, well, you could try doing that. So that would look something like this. And you can cut that from the middle. And you see there would be 1, 2, 3, 4, 5, 6, 7. 7. And now you're starting to pick up a pattern. You could keep drawing 4 to 5, but now you kind of know what's the pattern already. See, we add 2 from 3 to 5. 2 more. And if that's the pattern, we add another 2. This would be 9 plus 2. This would be 11, and so on. So if we wanted 12 folds, we could think about what's here. So what if there was a number 0? There's no 0 over here, but I'm just doing this to help us visualize. So the pattern is plus 2. So for number 0, that would be plus 2, which means that this would be a 1. So the pattern is 1 plus 2n. What is n? Well, n is just the variable, just the letter that we usually use to represent the number of the term. So for example, this would be the first term, second term, third term, fourth term, fifth term, all the way until the nth term, right? So just like the nth term. So we want n this time. So this is the expression, this is the pattern, but n is the number of folds in this case. We're trying to find how much pieces there would be if there were 12 folds. So we would replace n with 12. All we have to do is calculate. So this would be 2 times 12. We do multiplication first according to the order of operations. 2 times 12 equals 24. 24 plus this 1 over here is 25. So in total, there were 25 pieces cut. So the objective of this problem is to just get used to making tables. This would be the solution we're going to be using for the method we're going to be using for every other problem. So it's always good to get used to your algorithms, your number algorithms, your repeat algorithms, and your tables, and finding patterns. So thank you for watching and see you in the next problem.